In the cold silence of the high-altitude sky, the B-2 Spirit bomber cuts through the air with its unmistakable silhouette, a dark, sleek triangle gliding thousands of feet above the Earth. Designed for stealth, it evades radar with ghost-like precision, built to penetrate the most defended enemy territories and deliver devastating payloads. But as technology evolves and threats adapt, even this $2 billion marvel is not invincible. In the shadowy chessboard of modern warfare, how an adversary could launch an attack against the B-2 bomber is a scenario that military strategists and defense experts constantly evaluate. It all begins with detection, a monumental challenge. The B-2's radar cross-section is as small as that of a bird, its special radar-absorbent material and unique shape deflecting enemy signals. Traditional radar stations, even high-frequency early warning systems, struggle to get a lock. But new technologies, such as over-the-horizon radar, low-frequency systems, and quantum sensing, are emerging from adversarial nations looking to crack the B-2's invisibility cloak. The enemy must combine multiple tracking techniques: infrared satellites to trace the heat of engines, low-frequency radars to detect shape, and perhaps even AI-powered systems that analyze deviations in weather and sky temperature patterns. Once detected, the next phase is engagement. No ordinary missile can reach a B-2 on a deep penetration mission, especially when it's flying above 50,000 feet at nearly subsonic speed. That's where integrated air defense systems come into play. The adversary might deploy a layered response, starting with advanced surface-to-air missiles like the Russian S-500 Prometheus or the Chinese HQ-19. These missile systems are capable of targeting high-altitude stealth objects, relying on long-range radar and kinetic kill vehicles to take down airborne threats before they can unleash destruction. The attack would likely involve multi-vector coordination. Enemy early warning systems would feed data to interceptor bases. Ground-based launchers would be activated, and hypersonic or anti-stealth missiles would be launched in a coordinated strike. The missiles, guided by radar and infrared homing heads, would attempt to pierce through the B-2's countermeasures, including electronic jamming and decoy flares. With precision maneuvers and the help of GPS-denied targeting systems, they would aim to reach the bomber before it crosses into its strike zone. Another possible threat comes from the air. Fifth-generation fighter jets, such as the Su-57 Felon or the Chinese J-20 Mighty Dragon, may be dispatched on an intercept course. These jets, equipped with AESA radar and infrared search and track systems, could vector toward the B-2's predicted trajectory. Coordinating with ground-based systems, these fighters could launch long-range air-to-air missiles like the R-37M or PL-15. Their only hope lies in tracking the B-2 visually or via passive detection methods, since active radar might still fail to spot it. A cyberattack is another potential method of engagement. Disrupting the bomber's onboard systems or communications mid-flight could leave it vulnerable. Adversaries might attempt to jam GPS signals, flood satellite links, or inject false data through electronic warfare. If the B-2 loses connection with its navigation or targeting systems, it could be forced to abort the mission or enter a compromised airspace. Drones also play a role. High-altitude unmanned aerial vehicles can be deployed as airborne radar pickets, increasing the chances of passive detection. Swarms of low-cost drones might be used to saturate the airspace and relay real-time data to missile batteries. Though drones cannot attack the B-2 directly, their presence narrows its options and informs enemy operators of its exact location. In the final moments of an attack, everything depends on timing, coordination, and the element of surprise. The B-2 bomber, with its advanced countermeasures, may deploy radar jammers, maneuver evasively, and release decoys. But if the missile closes in within seconds, the bomber's fate depends on the effectiveness of its defensive suite. A direct hit could destroy one of America's most prized assets and signal a new era in the vulnerability of stealth aircraft. Yet, despite the complex layers of attack required, taking down a B-2 remains extraordinarily difficult. Its stealth capabilities, range, altitude, and onboard defense systems make it one of the most survivable aircraft in history. However, as new missile systems, hypersonic threats, and advanced detection technologies rise on the horizon, the B-2 is no longer untouchable. In modern aerial warfare, no machine is immortal, only those continually evolving survive the skies.